Alright, lesson 3.3, solving equations with variables on both sides. So we've seen how to do that when we have variables on both sides. We're going to look at two final cases. All the problems we've looked at so far have ended with an answer. X equals 3, x equals 10, x equals 59, x equals negative 43. There have been one specific answer that number is, if you substitute it in on both sides for x or wherever x may be, it makes the equation equal, it makes it balanced. There's two other cases. One case is an equation with no solution, meaning there is no number in the entire universe that I could plug in for x here and here that would make this equal. And let's see what that ends up looking like. So let's solve this. Looking at the left side, is there anything that can be simplified? Yes, there is. We can distribute. So I get 5 times 2x is 10x minus 5 times 1 is 5. All right, equal to 10x. This left side is simplified as far as it can be, and as is the right side. So now I go to get the variables on the same side. Well, they're both 10x, so it really doesn't matter, but all right, I'll subtract 10x to both sides, from both sides, going along with it. That cancels, negative 5 comes down, and over here, 10x minus 10x is just 0. This is an example of no solution, and this is why. Negative 5 does not equal 0. So that's not even true. So right off the bat, that should tip your hat that there's no solution. Secondly, there's no variable here. So we aren't finding what the variable equals. We just have two numbers that don't equal each other. So again, no solution. And then sometimes you might want to, we'll bring down a different color here. I also might, if you have number not equaling to 0, I like to put a big N here, kind of as a hint. No solution, okay? And when we solve graph equations in Chapter 8, we'll see what this actually means, why there's no value of x that will make these two equivalent. Because we'll look at the lines, and really it means that the two lines are parallel. They'll never intersect. But we'll come to that in Chapter 8. Right now, we just need to make sure we're really solid with equations. So letter B, simplify the left side by distributing. So 4 times negative 2 is negative 8, plus 4 times 3 is 12x equals 12x. Now you might say, oh, 12x, 12x, you already know it's no solution. But if you happen to not catch that, you would go ahead, get the variable on the same side. Negative 8 comes down, those cancel. 12x minus 12x is 0. Uh-oh, negative 8 does not equal 0, so again, no solution. Okay, and this is the work I would want to see, even if you do recognize at the first step that it's no solution. I want you to step it out for me all the way. Now the third case rather, is solving an equation with all numbers as solutions, meaning every single number in the entire world, all the decimals, negatives, positive fractions, everything, is going to make this side equivalent to this side when you substitute it in for x. I could put a 1 in for x and it would make both sides equal. So let's see what happens. This side cannot be simplified at all. 6 plus 2 is already simplified. But on the right side, it can be. So I'm going to distribute and get 6x plus 2. Whoa, we have the exact same thing. So whenever I plug in for x here, maybe I plug a 1 in. 6 times 1 is 6 plus 2. This side's 8. Well, obviously, I'm plugging a 1 in here too. 6 times 1 is 6 plus 2 is 8. So they equal. They're absolutely the same. Again, though, if you didn't recognize that, for some reason, we would go ahead and get our variables on the same side. So just like before, we're going to subtract 6x. Those cancel, 2 comes down. Those cancel, 2 comes down. Now here, 2 does equal 2. So it's true. And we don't have a variable. It's not there's x equals something. So it's not that x is a number. It's just that these balance, they're true, so it's all solutions. And the real thing is all real numbers, which in class I show you is that symbol. But if you just write all solutions, you're good. Same for letter B. We're going to distribute, so we simplify. I get 14x plus 21 equal to 21 plus 14x. They can be in any order, commutative property says, but this means they're exactly equivalent. But I would maybe go ahead and finish solving it if I didn't notice. Those cancel, 21 comes down. On the right side we have 21 equals. Those cancel, not equals. So 21 equals 21, which is a true statement, all solutions. Okay, again, I do need to see this work, so that I know that you get a star, you understand what you're doing. All right, last problem, find the perimeter of the square. Now, if we look at this square, we know a square has all sides that are the same. This side equals this side equals this side equals this side. But then why do they use two different expressions? Well, that's because these two are equal, even though they don't have to be the same thing. Let's just say, for example, what I mean by that is if we had a square and each of the sides was 12, I could say that this side was 3 times 4, and I could say that this side is 6 times 2. They're both 12, aren't they? But they're written with different expressions. That's exactly what's happening here, two different expressions. So to find the perimeter, we have to go off of that. I can label. Sometimes our first step is to label all the sides. They're all the same, but I just went with the opposite expression. But now we run into a problem because they don't tell us what the perimeter equals. So I can't say this plus this plus this plus this equals anything. We can't do that. Instead, we have to go off of what we know. We know that a square has all the same sides. So like we said before, 5x plus 14 is going to equal 6 plus x. So let's go with that. 5x plus 14 equals 6 plus x. Now if I solve this, that's going to tell me what x is. So I'm going to go ahead and subtract. We get 4x plus 14 equals 6. Subtract 14 on both sides. I get 4x is equal to negative 8. Divide by 4, divide by 4. X equals negative 2. So now I know what x is. And now I can use that for the second step. I can plug that into one of these sides. So now I have 6 plus negative 2. So my side is actually 4. But now let's check this one. If I plug negative 2 in here, I should get 4 also. 5 times negative 2 plus 14. Negative 10 plus 14, which is 4. So we did it right. This is 4, which means that's 4, and that's 4. So the second step is to substitute x into the side to find the length. Now the last step, since we want to find the perimeter, that's what the original problem asked for, we want to go ahead. This is 4, 4, 4, 4. So step 3 is find the perimeter by multiplying or adding all the sides together, or multiplying the two opposite sides and adding. But by finding the perimeter, we're going to add 4 plus 4 plus 4 plus 4 and get 16 units. And there we have it. These problems are a little trickier, but if you remember these 3 steps, you'll be set. Okay, have a good one.